Hello guys, very happy morning to all of you. And now we are just going to start the next lecture on the welding. Okay, so without wasting time, let us get started. Because in before thing I just explained about you each and everything, because what are the arc flow and how the arc flow is occurring and how why the magnetic flux is being varying and how much the diameter of the bead and each and everything should be. I just explained you about that thing in a detail way. I just think so. So now we are just going to see about the gas shield. Okay, so in gas seal is so much important thing, guys. See, there will be an electrode and it means the electrode should melt and we will supply the shielding gases. Okay, we it means we input gases and we it means that gases need to react and inert gas is blown into the weld zone to drive away the atmospheric gases argon, hydrogen, helium and nitrogen and carbon dioxide also being used. You can see, so this shielding gas prevents the atmospheric reaction with oxygen. So no need of filler material and coating electrodes is no need of flux material and coating electrodes, and it is clean welding. Okay, nitrogen behaves in a gas if the temperature is below 3000 degrees Celsius. So nitrogen has to behave as in a gas below 3000 degrees Celsius. Okay, so nitrogen and carbon dioxide are limited use only, so not so much use. So you can see argon mostly used as 99% and helium is very costly. So argon is ionization is easy. Okay, so small it requires only small voltage. It is used for welding thin sheets. Next one is helium is most expensive and has better thermal conductivity, used for thicker sheets. And next one, copper and aluminum, and helium is being used. Okay, stainless steel only, you can see copper and aluminum, helium is being used. So helium is used under stainless steel only 12% of chromium is using there. And in this one steel welding, argon mostly used and carbon dioxide. So it means sometimes arc of the shielding gas is unstable, least expensive and deoxidizers is treated. Okay, deoxidized I think so, oxygen more. So carbon dioxide heavy gas, therefore the covers the weld zone. So sometimes you can see stainless steel and mild steel, mostly expositional welding and diffusion welding we used to join. And CO2 is heavy, yes, definitely CO2 is heavy. So that's why after the burning of the forest fire, mostly CO2 gas will come out, and later on the outlet gases of CO2 just covers the entire bed. So the fire is being stopped. Okay. So next one is carbon arc welding. So you can see it is carbon arc welding. It is non-consumable electrode. So arc produced between carbon electrodes and as well as the work. Shielding is not used. Okay, in the shielding because it's not consumable electrode. And next one is no pressure and without filler metal can be used and may be used in twin arc method. Okay, that is between two carbon graphite electrodes. Okay, so you can see the straight polarity is always recommended on the carbon electrode welding and carbon arc is welding straight polarity. Yes, both. You can see straight polarity, yes, definitely, because in straight polarity what we mean that the electrode is minus and the workpiece is positive, and you can see 80% of heat goes towards this one. Electrode should not melt, yes, and then least heat and neither the workpiece. Okay, so straight polarity DC is used normally. It means for generally non-consumable electrode mostly straight polarity is being used. Okay, this thing you want to just keep in your mind. For generally non-consumable electrode mostly straight polarity direct current is used. The next one, tungsten inert gas wasting. So arc is established in non-consumable tungsten electrode workpiece. Tungsten not a good electrical conductivity, so we add thorium and zirconium, so now it becomes a good conductive material. Okay, now it can carry the good current as well as the electron emission is very much good. So zirconium is also being used, it means sand. So tungsten electrode, you can see this is tungsten electrode and this one is shielding gas and also the water for the cooling, and it means everything guys non-consumable is generally used for, it means straight polarity. It means the electrode will be minus and the workpiece will be positive. Filler metal or filler rod we can use arc length installed and so stable, easy to maintain without filler metal, very clean weld because shielding gas we use. Okay, so next one you can see all metals and alloys can be welded, yes, definitely. Aluminum, this mostly guys in the tungsten inert gas welding most of the time is aluminum because why we are just not because of the density difference. Okay, and it doesn't diffuse so much quickly. So sometimes while welding aluminum on aluminum, you can see because while it's lead to formation of Al2O3, so more defect. So straight voltage is released. Okay, so you can see voltage is 20 to 40, just so much lesser. When you can see for straight polarity DC current how much more current we are using, but reverse polarity less current we are using. Shielding is okay, torch is a normal thing. Now when so what it means consumable electrode. You can see gas metal arc welding. Okay, gas metal arc welding means consumable electrode in the gas shield is in argon, helium, mixture of two also used in shielding gas. Okay, shielding gas generally you can see this one, the black straight line. So while you are just it like a gun. Okay, while you are just pressing, the electrode will come out as well as the shielding gas also will come out. You can see the electrode comes out, the shielding gas also will come out, and no coating of electrode because the shielding is provided. Arc is between workpiece and an automatic feed bare wire electrode, no coating means because of the shielding as done. Okay, any metal can be welded, but arc primarily used for non-ferrous welding. Okay, non-ferrous welding. Before thing is generally used for metals, especially for ferrous. This is for non-ferrous. Okay, tungsten inert gas welding ferrous mostly, and big non-ferrous mostly. Okay, why when welding steel, some O2 and CO2 is usually added to improve the arc stability. Okay, while welding steel, some O2, it means some oxygen and carbon dioxide is usually added to improve the arc stability and welds better reduce. It means faster and economical than tungsten and gas welding. Okay, a straight polarity or DC electric current is used for deeper penetration and spare transfer. Deeper penetration, spare transfer, and ability to produce smooth welds with a good profit. Okay, these are just an extra questions. So next one, submerged arc welding. So for this, I will just show you the video. I think so you can see it. So this is submerged arc welding. You can see the flux motor is bit more, and as well as we are just doing the welding. See the powder has been poured and back we are just doing the welding process. Okay, this has been sucking. Okay, I think you are getting the point. So you can see it means this one submerged arc welding is welding, and it is done inside some sands like arc submerged and welding happens. A thick layer of granular flux is deposited just ahead of pour electrode and consumable electrode. Okay, an arc is maintained between the blankets of the flux with only a small flux being visible. Okay, so coating also no needed as definitely. Bitch it means yes. So a portion of flux melts and molten flux and provides a thermal insulation. So here the slow cooling rate is occurring. Okay, produces soft and ductile welds. Okay, ductile welds. So another thing you can, while we are just welding, yes definitely here no heat goes out. Okay, because fully the flux powder has been coated, and especially if it can occur a slow cooling means you can see soft and ductile metal will get it. But if it's hard and fast means hard and brittle metal will get. So mostly suitable for the flat butt and or filler weld in low carbon steel. It means less than 0.3% of carbon. Okay, low carbon steel only less than 0.3% of carbon. Okay, it means I think so it means carbonless we can use submerged arc welding, but it means submerged arc welding we can also use a vacuum pump. This one normal thing. So only diameter, bigger diameter we can use at that point. It looks flat, but the flux is absorbed by the side by vacuum cleaners. It is done outside of the pipe and inside we can do. And you can see if steel contains less than 0.3% of carbon, whether you cool it or hot it or dip it in water, we can't increase the hardness. Okay, it remains as it is. Okay, the next thing is it means 0.3% of carbon you can just do this kind of thing easily, and it means most of the other thing is doesn't need it. And this process not recommended for high carbon steel. Yes, high carbon steel we can do. And you can see because high carbon steel, while we are hitting the mismatching will occur, and tool steel, aluminum, magnesium, titanium, lead zinc we don't use. This we don't use because more molten flux and metal starts to react and wastage will start to occur. Okay, next one is it is cleaner than tungsten inert gas and metal inert gas welding. Okay, next one calculation. So characteristic: high speed, high deposition rate. Yes, high speed and high deposition rate, then big and thick and deep penetration because no heat loss and concentrated load, and high cleanliness due to flux actions. Okay, next one you can see flux also melts while welding or it means flux also melts while welding, and after finishing welding we chip them. Yes, definitely, I think so. I would have shown you here. Hence it becomes very clean workpiece. Okay, so next one is advantage. So wire electrode are inexpensive. Okay, that wire electrode is inexpensive and no weld spatter is definitely, and near 100% efficiency and lesser electric consumption is in there. And limitations: excessive flux handling. Yes, definitely, excessive flux handling, moisture contamination of the flux. Yes, definitely, larger grain size structure, welding only horizontal portion only behind it. So and actually chemical control is so much important because it may react with the atmosphere. Okay, I think so you understand. So next one is atomic hydrogen welding.
हेलो दोस्तों, आज हम जानेंगे एटॉमिक हाइड्रोजन आर्क वेल्डिंग कैसे।
I think so you can understand. So you can see two instant and you have the electron. So the hydrogen is passed between these kind of things. So the heating occurs each and everything. So you can see arc welding, tungsten inert gas welding, and MIG welding, metal inert gas welding. So see in arc welding how much the spatter has been formed. You can see the weld spatter, and see in tungsten inert gas welding how much the weld spatter has been there. And but see in the MIG welding, it's so clean. Wow. The submerged arc welding. So atomic hydrogen welding, you can see an AC arc is formed between the two tungsten electrodes and along a stream of hydrogen feed. Okay, the hydrogen is been absorbed. It means hydrogen absorbs the energy by AC. It means alternating current tungsten electrode and breaks down into atomic hydrogen. H2 is H and H, and with the observation of it, because I think so I have shown in the video. So this thing we feed into the high velocity, and this atomic hydrogen travels at very speed and it hits our piece and releases heat. And after that the energy decreases and again decomposes. Okay, you can see this one hydrogen while going to the AC it splits, and after splits means after releasing the heat to the workpiece it just goes out as hydrogen also. Okay, temperature you can see literally 3000 releases, literally so much hotter. And hydrogen gas itself here it acts as shielding and used for the thin sheets, small diameter and small diameter wire, low thermal efficiency than arc welding. Ceramics may be welded here. Okay, AC is used. Ceramic and AC is been, that's the most important one. And next one is weldability and fabrication. So weldability means how easily we can just weld it. Okay, the weldability of material will depend on the specific welding joining process which time you are using. So next one, frequency. Friction welding material can't be done by yes, definitely friction welding. So what kind of material, it means what kind of welding we need to do, that kind of welding only we need to do. And tungsten inert gas welding, you can see cannot be done by submerged arc welding. So it's so important. So for resistant welding of you can see consider quality. So it is used necessarily to remove the oxides immediately before the welding. Yes, definitely for resistance welding. Fabrication welding test used to determine the mechanical property required for satisfactory performance of the welded joint. It means ascend or it means generally it means mild steel we can easily weld, but aluminum is so much difficult. So mild steel and cast iron, copper and aluminum. So aluminum is quite difficult to weld, but you can see mild steel we can weld easily, and the easy of welding depends on the thermal conductivity, thermal expansion and surface condition also. So you can see thermal expansion. So it means both of the metal should be same. Steel means it should be same. Different material welds, so it means copper if we add it means so much difficult. At room temperature it means contraction and expansion occurs and consider. So steel Contracts, it means general steel consists, and aluminum contracts also it means copper content different quantities. Okay, so due to this cracking also will occur. And next one you can see same workpiece, it means same workpiece and welding same, okay, then no problem, but different working it will cause to a lot of problem. So junction may break. Okay, so next one you can see causes of aluminum. So why the aluminum is so much difficult means the oxides coating in the aluminum alloy sometimes causes difficulty in weldability. Okay, because you can see this one here the aluminum oxide is present, here the aluminum oxide is present. Suppose if you just weld it means the welding material and as well as the oxide material doesn't have that, it means adhesion to, it means cohesion to easily merge to diffuse. So when we pull the workpiece breaks, and thus this is because of El2O3, and this is high because this thing aluminum has high thermal conductivity, and it has very short temperature in between liquidus and the solidus when the liquid is viscosity is very low. Okay, because this short temperature in the liquidus and solidus, you can see water has 0 degree to 100 degrees Celsius, but aluminum is not really so much lesser, and aluminum is also poor absorber of the laser light, so that's why mostly the aeroplane has been coated with the aluminum. So during fusion welding the aluminum would oxidize easily, so special flux and protective inert gas atmosphere must be employed. So friction welding, TIG welding is good for aluminum definitely because of the friction, and TIG because for aluminum AC current is used because of the high frequency. Okay, so next one cast iron. Cast iron also is so much difficult, but sometimes what's the main problem is the carbon particle doesn't allow the weld materials to easily attack because carbon is hydrophobic. Okay, it repels most of the thing. So while coal are taken from the mines, coal and stone both will come, and we take them into the coal mine, and it means sometimes you can see stone also comes coal, and we cannot take it so much. It means bothly the coal and the rock will be same. So while washing, what happens, coal does not attract water, hydrophobic, so we can easily find it. So next thing, while temperature increases, thermal stress also increases. Then it is ductile material means, okay, it goes to the plastic deformation, but long time thermal stress withstand. Okay, that's it. So in ductile material it withstands the long plastic deformation, thermal stress, but brittle material so small, no plastic deformation, sudden failure will occur. So cast iron is comparable kind of brittle material, so it is more difficult to weld. Okay, generally guys ductile material is so much easy to weld, but brittle material is a little bit difficult to weld. Okay, so you can see it is more difficult to weld because of the high carbon content and brittleness. To reduce thermal stress, we preheat and post heat it. Okay, preheat is just before welding we heat it. Post it means after welding also we heat them. Okay, already welded, we don't have to cool, we are post it. Preheat, post it, and crack reduces definitely. Massive carbon deposit, hence density to form the area. So high carbon is been martensite will be formed. So martensite formation due to rapid cooling tends to affect the heat effect of them. So next thing you can see this microstructure are very brittle and crack spontaneously and reduced only by pre and post heating. Cast heating can be joined by oxyacetylene bracing and shielded metal arc welding. Okay, oxyacetylene bracing and shielded metal arc welding, and you can see oxygen adding little more, and this one here. So carbon 2% less preheating, and carbon 2 to 6.6% means preheating and as well as the post heating. So case of stainless steel, you can see surface chromium oxide will be there at the inside only, iron chromium oxide will be there. So surface generally the chromium oxide will be, and at inside iron will be. So if we, it means if this need to come out means testing need to place it. So how we weld the chromium oxide, it is difficult. So what, because it contains nickel as well as the chromium. Stainless steel 18% of chromium and 80% of nickel, 18 is to 80. So welding of stainless steel generally we use tungsten and gas welding. So first we grind them, we weld them, and elastic and electric arc is preferred over the welding of SS and heavily coating welding rods. While provide the shielding, okay, pre-cleaning must, and lower the arc current, faster weld travels, and while welding stainless steel becomes some SS are subjected to carbide precipitation. Okay. So next one is the ferritic stainless steel are generally less weldable than austenitic stainless steel because of post and preheat is required. Okay. So next one is also simple. So welding technology, backing, material support provided at the root, it means at the bottom we are just providing some kind of support to control the penetration, so that's called as backing. So base metal, I think so you know metal to be joined out of the base metal. So bead or weld bead, you can see bead is a metal added during a single pass of the bead. Okay, while we are passing, we are generally as a bead. So next one, crater. As electrode melts, strikes it to, it means strikes it leads to the form depression in the weld metal pool at where the, it means at point where arc occurs. So this one is a crater. So apportioned weld metal deposited per unit time. Filler weld, two metals fused at by corners, puddle a portion of the weld joint that is melted by the heat of weld. So next one is tack weld. Tack weld is little bit of like this. So generally we use laser tack weld. So after that we usually do the welding. Okay. So next one is means you can see weld reinforcement form factor. Okay, equal to W divided by R. It means weld with divided by reinforcement. Okay, I think so I can understand. So you can see weld with, this is one is weld with, this one is the penetration. So weld reinforcement form factor WRFF is weld with divided by reinforcement. So next one is dilution. Dilution is penetration area B divided by penetration area A plus of penetration area of B. Okay, I think the dilution is penetration area B divided by penetration area B plus of A. Okay, I think so you are able to understand. So next one is resistance building. So resistance building is such a simple thing, because you can see this is both side will just connect, and the internode will just heat and it will melt. Okay, you can see both heat and pressure are used. It is positive welding process. Heat is generated by the electrical resistance of the workpiece as well as the interference between them. Okay, so I think so you would have seen lot and lot. So you can see this is transformer and this is primary transformer, secondary transformer, more coil and less coil, and AC supply will be there, pressure cylinder will be there, and overall resistance will be low, but you can see the current will be literally so much high. Okay, here the voltage will be less but current will be so much high. Okay, up to 1 lakh. Wow, you can see current is so much high, and the current travels always where the resistance is less. Yes, definitely. And we hold the electricity flows, and each and every time now we will just do everything. So V voltage equal to V into IR. Okay, so you can see here, so current and pressure, and at the beginning we will just hold and we will just press and we will just hold, and within this certain amount of time you can see the welding current will be so much higher, and after we will just it means I think so you would have known what we will just force and we will just do each and everything. So post weld heating current is occurring. So he also, it means here also we give current, because after clamping we give additional pressure. So but while giving like this, the current is sooner solidification happens, poor conduct of metal may not be occur. So it's generally, it means why the post heating occurs means so generally after giving so much amount of current, sometimes it means the current may be low, it means the welding might be not be proper. So to proper welding we just give excess supply. I think so you can see this one. So the negative will be under the welding time is there. So next one you can see pressure applied changes for weld cycle. Due to the pressure, a low temperature needed, it means low temperature needed than oxy-fuel and arc welding. So they are not officially as solid state welding, but a little bit of weld occurs. They are not solid state welding, but little bit of welding. So you can see very rapid and economical, extremely well suited for automated manufacturing. So not used any kind of tack weld, no filler metals, no flux, no, it means shielding has been used. You can see the welded attachment will be there, and the continuous welded attachment means it's seam welding. So very rapid, fully automatic possible, and conserve materials and the filler materials shielding. So skilled operators not required. Dissimilar metals can be joined as like high carbon steel, low carbon steel, high reliability and high producibility, high cost, and only lab joint is definitely skilled maintenance person is needed, surface is needed. It's okay. So this thing is not that much important, but okay, resistance spot welding and resistance seam welding, projection welding, upset welding and precision welding has been there. So these are the other welding process. So resistance spot welding, resistance seam welding, projection, okay. So the resistance spot welding, you can see this is the volume of second. So they may be cylindrical or spherical or cylindrical. So volume equal to, we can need it. And next one, heat required to melt is definitely mcp delta t and lambda of latent. So the sensibility as well as latent is required. So next thing is, for 1 millimeter cube, how much heat is required? Okay, that is so much important. Okay, heat required or transferred to sensibility as well as given the question. So the electrical resistance, you can see, Q equal to I square of RT. This is melting efficiency equal to HM divided by H of I. Okay, here heat transfer likes it means welding work out. Okay, next one is arc welding. Here heat loss is more, but here the heat loss is so much lesser. Okay, here the heat transfer doesn't occur so much. So this resistive welding is so much good for each and everything. So resistance seam welding. For example, I'll just show you the video so you can have a clear cut view. So I think so you're able to see that. So you can see. So you can see the resistance welding is another. So this is seam welding process. The continuous welding process will be occurring. So I think so you can see. Wow, see the welding how it has been occurring. See, this is copper. Okay, see the welding has been occurred perfectly. Oh, see, just by passing of the electrical current, see how much it is been made. I think so you're able to see this one. This is TIG welding. Okay, so you can see resistance seam welding. So continuous spot welding and spot overlaps each other. Pressure and current are discontinuous and rotation of the electrode is continuous. Okay, pressure and current time independent. Okay, time will be changing but rotation is continuous. And leak proof, especially liquids and gases, the cylinder we will use, and weld is made between the overlapping steel of metals. The seam is series of overlapping spot welding. Basic equipment is same as spot welding except that the electrodes are now in form of rotating discs. So timed pulses of current band is to form overlapping weldings. Okay, timed pulse, that's it. So welding current is a bit higher than the spot welding. And to compensate the short circuit of adjustment, shunting occurs. Yes, in most of the resistance welding, the shunting occurs because we are just clamping. So due to the clamping, the lot of shunting is occur. Shunting current loss little. Okay, for resistance welding, current loss due to more spat welding overlap. Okay, so for pipe welding, generally C welding is being used. Okay, next one, projection welding. So projection welding, I think so you can see little bit of projected area will be done and we apply the pressure and we will make this kind of projector towards the joining. Okay, now the pressure and current given, the current passes through the bulge part and strikes the workpiece and both joints. Okay, second hollow, this one I think so you can know. So limitation of certain electrode condition must be maintained continuously in one spot. Yes, multiple spot can't be done. Single part is not good, so we use for multiple levels. So projection welds overall the spot welding limitation. So dimples are inroads on the workpiece of the weld and locations at a large area. Okay, pressure. Okay, so current flows through the dimples and heats them and pressure comes dimples to flatter and forms a weld. So I think so you are known about this one. No projection, this one. So projection formed in the O size and multiple ends. Okay, this one also. Okay, so next one, upset welding. Upset welding is you can see friction welding a little bit. Made butt joint compared to lap welding. Pieces are held tightly and current is applied due to the pressure. They gets upset and held its reverse upset. Useful for joining gross and similar pieces. So friction welding, bulging. Okay, making electrical resistance welding. Pipe starting from metal piece to and substantial. Okay, this one normal thing only guys, not needed to learn so much. So next one is flash welding. So flash similar like a camera flash and on and off. So it is similar to upset welding except the arc rather than resistance welding. So definitely, so you can see the gap is made and the heat is, it means the current is passed between the two sides, and later we will apply pressure and we will just weld. It is similar to arc welding. So you can see this one fixed and move like this only will be there. And percussion welding. So here we give capacitor. By using the capacitor we weld similar to the flash welding except arc passes by the rapid discharge of the stored electrical energy. Arc duration just 1 to this 1 milliseconds. Okay. So next one, high resistance also same. It is similar to seam welding except high frequency current and production of multiple turbine pipe, and is been used the sections of I-beam sub-beam fabricated by this. Okay. So I'll just see this one. So electron beam welding. So electron beam is, you can see, micro welding used to chip seld circuits. For electron beam welding only we pass here electrons. Very high temperature X-rays will form. Okay, as the electron passes it tends to ionize the gas. At the end of work which may not be melt. Okay. So vacuum chamber is used. Yes, definitely vacuum chamber is used. That's only the electron flows in a stable path. Beam of electrons is magnetically focused on workpiece in the vacuum chamber. Heat of fusion is produced by electron deceleration. Precision beam control, deep weld penetration is being used. So this is high voltage and cable receiver. Like this you can understand. To focus at the point, to move it means electron beam is used. So next one, laser. Laser also same. Laser beam welding used to focus beam. It means provides power in intensities in excess of 10 kilowatt to 70 meter square to this one. Low intensity, high intensity. Gas laser, less intensity, very thin heat affected zone and little thermal distortion. Filler metal and inner gas shield, and may or may not be used deeper penetration over vacuum layer. Possible to weld where without removing the insulation wire. Okay, by the laser beam which is able to weld easily without removing the insulation wire. Okay. So commercial use more and laser electron not more commercial. Okay, that's it. So next one, forge welding. By it means we will just melt and we will just heat and we will just, it means we will just beat and we will just paste. That's it. Next one, friction welding. Friction, heat, yes, friction it we use, and mostly one fixed and other is rotating high speed. At end pressure suddenly applies, and then no clean due to friction. Yes, due to friction everything will be removed. It means the oxides will be removed. Power is about this one, and axial pressure depends on the strength and hardness of the material to be joined. Okay. You can see wide variety of metals. Combination of metals can be used to, such as aluminum to steel, and grain size is refined and changes strength smooth than base metal. And generally one round and one flat, two flat can be welded. So one component must be ductile, another component must be brittle. So it means if both are brittle, crack may absent and it will lead to breaking. So that's why we are using like this. So low pressure at the beginning and leads to cleaning of the final high pressure. So frictional factor is equal to nu into pressure into area. Okay, this one. So nu into n. Okay, normal reaction. So frictional torque Ff into critical radius. So frictional power 2 pi n divided by 60 of Tf. Okay. So next one is ultrasonic welding. So ultrasonic welding, it means high frequency is used, 10 to 2200 kilohertz supplied, and due to the ultra, it means you can see 2 lakh times it means striking the metal at a second, and surface are held together under the light normal pressure. Temperature doesn't exist one of the melting point. It's ultrasonic welding comes under solid state welding. Metal and non-metals we can weld. Ultrasonic transistor is same as ultrasonic machining. So only lab joints we can do, but joints we can do. Weld thick materials and fails and wire on the attracting thin sheets to the heavier sections. Okay, weld thin material sheets and foils wire on the attracting one. So max thickness is 2.5 mm for aluminum. So number of metals and dissimilar metal combination. Non-metals can be welded such as aluminum, ceramics and glasses. So temperature we don't give, it itself heat is produced. Equipment is simple and reliable. Less surface penetration and less energy needed. So joining dissimilar materials in bimetallic, making microcircuits, electrical contacts, welding refractness and reactive metals, bonding ultras. That's it. Okay. So guys, let's finish the video and let me see in the next video. Until then, Take care. Bye bye. Have a good day.